Hello students, welcome to Showups or classes. So in this particular lecture we will solve the question of TIFR 2022 paper. So let's look at the question number 21. So for a nilpotent matrix A belongs to this M of n R, then we have let exponential of A is given as summation of n to 0 to infinity a to the power n by n factorial is equal to this ID plus of 1 by 1 factorial plus a, this is a by 1 factorial, then it is a square by 2 factorial, so plus up to which this mn belongs to R. So the question is given that if A is a nilpotent matrix such that the exponential of A is ID, that is identity, then A is a zero matrix. So you have to find whether it is a true or false statement. So we have been given that as it's given, you can see over there, is as exponential of A is equal to the identity. This implies that A by 1 factorial plus A square by 2 factorial plus is up to this equal to 0. So now, if we write this, A by 1 factorial plus A square by 2 factorial plus up to this A to the power m by m factorial is equal to 0, since why this A is already mentioned that A is a nilpotent matrix, okay, of index m plus 1. Okay, so we know that this is apart from a theory that this nilpotent matrix is similar to upper triangular matrix, right? Upper triangular matrix, I'm writing it in short, the UTM. So you will see that, so what happens, so as the power increases, right, the respective non-zero entries of matrix decreases. So let us see this, how it is happening. So suppose this A, so we have this, it is mentioned that power increases, the respective non-zero entries of matrix decreases. So let have this, let A be a matrix, so you can write it as A13, A1n, A23, A2n, right? So here all will be 0, and it is A3n, and here it is an minus 1, last will be an, and the last row will be 0, right? So this is A. So if we do this multiplication, suppose if we increase this A square, it's A multiplied by A, then the matrix will get, it will be again 0 0, B of 1 3, B of 1 n, 0, it is B of 2 n, it will be again 0, it will be of 3 n, right? So leaving all the rows, you can see, you can check, so this will also be 0 and the last row will itself be 0. So from here we can infer that A is a 0 matrix, right? So in the question we have been asked that whether this, if A is a nilpotent matrix such that the expression exponential of A is the identity, then A is the 0 matrix, whether it's true or false. So it is, in our case, this answer stands true.